Welcome to the Desalination Market webinar this morning. It has several purposes. One, we're going to be providing information on the desalination market for all the different products. Secondly, we are focused on the interconnection of all the combust, flow, and treat products involved in liquids, gases, and free flowing solids in desalination and every other major industry. And we are running this series of IIoT and remote O&M webinars showing the interconnection of all these different components in each of these processes. So desalination is one of many, and we will be continuing to do this on once or twice a month at the very least. So let's look at the size of the market first here. Desalination is growing faster than the total potable water market. If you look over on the right-hand side here, you'll see that next year there'll be $1.4 billion spent on pumps, but the top 40 owners and EPCs will capture about 40% of that market, which will be over $500 million. The same thing in membranes. The top 40 will purchase over $400 million worth of membranes, $500 million worth of valves, $80 million worth of what we call macro filtration equipment, which would be like gravity filters and presses and things, and $80 million on cartridges. In terms of control, guide, and measure, which is really a lot of our focus of IIoT, $360 million will be spent, on the software and services, which would be remote O&M and that sort of thing. $760 million on control, and then your instrumentation, measuring the liquids and gases, and feeding that information to your remote O&M, $320 million. So these 40 companies will be making purchases over $3 billion. And this is a central theme of many of our initiatives, which is with remote O&M. You are going to have a relatively few number of people in a relatively small number of large companies making a very large percentage of the flow and treat component decisions, and they'll be doing so based on total cost of ownership analyses that they are continually receiving from all these operations. So due to the increased usage of remote monitoring, the purchasing decisions will be made by relatively few individuals, as we've said. And so you have some very large owners like TAQA in the Middle East, and we'll be talking more about them in the future. There are a lot of technology trends, one of which is the reverse osmosis instead of distillation, and those costs are coming down. So we see that that trend is going to continue. So the remote monitoring and control assures that the proper treatment chemical additions are made to minimize membrane fouling. Energy efficiency is also optimized through control of the primary and energy recovery pumps. There are other expenses that are shown on this particular slide, and I don't think it's appropriate to probably go into those. The bottom line here is that the desalination market will grow rapidly through 2020 due to increased water demands and decreased availability of alternative sources. Despite, though, a 70% growth in desalination capacity in the next 5-year period, desalination will still only account for 3% of the drinking water supply and less than 0.1% of fresh water withdrawal. So it's still got a lot of room to grow. The size of brackish water desalination market's less precise than that of seawater, and it involves what you mean by the definitions there, and we'll get into that. A big regional growth opportunity is in the Gulf Cooperation Council market, which is going to increase its capacity by 6,600 MGD by 2020. So that's a huge increase. Now let's get into brackish water. There's an extensive amount of very salty water in the ground in the western U.S. In New Mexico, approximately 75% of groundwater is too saline for most uses without treatment. So the state of Texas has abundant underground water supplies of 880 trillion gallons of primary brackish groundwater. The definition that they are using is total dissolved solids between 1,000 and 10,000 milligrams per liter. And because of some of the legal aspects, there's been a lot of effort to define what is brackish water. But needless to say, it is a different definition for many different people. So when we're talking about the size of the market for brackish water treatment, it can mean a lot of different things.
So 2015.
And then one of the aspects that's also interesting here in the United States is with shale gas and shale oil, you have the flowback solids that have 4 or 5 times the amount of sodium chloride that you would be getting in seawater. So you have a very similar situation to a very concentrated seawater system with hydraulic fracking backwater, and that's another big market. So from there you get on to zero liquid discharge systems that are used in many different plants. And so I've asked David Martin of ProChem to join us today and maybe provide some insights on what they're doing in the ZLD system area. And David, we have 3 slides starting with this one and the 2 others. Would you like to take us through your activities here?
Sure. Thank you for having us. As it shows on the slide, we do a membrane treatment system on wastewater to try to recover as much wastewater as possible through the iPro. That used to be called the IH Pro, but we dropped the H, so it's the iPro. Typically, we try to pre-treat to remove scale-forming ions to make the system run as optimally as possible. And we can achieve 90 to 95% reuse.
Very good. Now we can actually show some diagrams and charts here. This shows performance, and the ELG would be the permit for emission limit guidelines that EPA set up for power plants and others. And so what have you been able to achieve here?
So we've been able to achieve 90 to 95% recovery. This particular waste stream had an incoming TDS of about 28,000, and we got to about 86 on TDS with the polishing RO. If you notice there, the RO feed is higher than the system influent. That's because of some of the phys-chem treatment we do in front of it.
I see. And so the bottom line is that you're able to meet the state ELG limits with room to spare. Is that correct?
Absolutely. Or reuse the water back in the scrubber, or even do a polishing step and reuse it back in the boiler.
Which is an important aspect, and particularly when it comes, for instance, to new gas turbine combined cycle plants which are being installed here in the United States. In some cases, they've opted to go with a system such as this rather than have any wastewater discharges to waterways. And one of the reasons has been for some of these quick build projects that they eliminate the need to wait for water permits. So it can extend for reasons other than just the value. You know, these are sometimes in heavy rainfall areas, so it's not just the savings in water, but the avoidance of the permit.
Yeah, that's true, and we're doing some work in the combined cycle market as we speak.
And that's where you have concentrations because of cooling water and other things that you know, you get evaporation, so you can get pretty high solids content, even though really there's no fly ash or anything involved here.
Correct. Yeah, we can get up 98% recovery or so in the combined cycle market.
Yeah, that's yeah.
What's on the screen now is a typical process flow, a simple process flow from a FGD system. Go through the EQ tank. We do some physical chemical treatment process. Again, try to minimize scale-forming ions. We can go through a microfiltration system, which is the iMicro system. The iPro system is the high pressure RO, and we run that in a batch continuous process to try to cycle up as high of a TDS as possible in the iPro system. And then if you need to polish it, we go through the BPro system, which is a adaptation of a brackish water RO. So based on a TDS set point, the iPro system will reject concentrate to the concentrate management system, which could go for solidification, brine crystallization, and in some cases we can seed back in through the phys-chem process, utilize some of the concentrate as coagulants for precipitation and get a higher recovery. It's all dependent upon the water we're receiving.
Yeah, that's an interesting aspect of it, is the use of the concentrates there. There are 3 or 4 different valve manufacturers who are participating in this webinar. Would you want to just, you know, because you've got slurry valves and you've got liquid valves and so forth, would you want to just maybe spend a minute or so? Are these valves that you're purchasing from the various different valve suppliers?
Yeah, they are. I mean, they're automated valves, typically with feedback, so we can tie it into the remote monitoring to make sure that the valves are open, valves are closed, and show that. So we're always looking for the better mousetrap.
And then finally, to talk about this remote O&M on things like valve performance and membrane performance and so forth, you've equipped yourselves to help the customers on a continuing basis, have you not?
Absolutely. Our systems are fully remote monitoring, custom design systems, so we typically monitor the influent pressures, conductivities, TDS set points, as well as the effluent. And you see a really nice graph that shows the whole batch continuous graph and can tell everything that's going on with the system, with the chemical feed rates, to ensure that the system can be run with minimal operational labor.
And then too, there are important aspects like minimizing chemical consumption and avoiding, at the same time though, avoiding the buildup and having to shut down your membrane system. So it's a delicate balance, is it not?
It is. It's a delicate balance, but having the monitoring system and some of the triggers, if you see a change in the transmembrane pressure, it can trigger a automatic clean in place of the system. And then if that is more frequently than typical, then it may have to go into a membrane replacement, which is typically on an annual basis or every 6 months.
Would you have periodic online meetings or discussions with the end user and be making suggestions to them as well?
Yes, yeah, especially if we see some trending analysis as we're reviewing the system that we don't like. We try to get out in front of it to make sure that everyone knows what's going on with the system and we make the proper adjustments.
Well, thank you, David. I think that was a very good summary of your activities, and we'll look forward to having your input in the future here.
Thank you.
We're not going to spend any time this morning on the Chinese desalination market. This, for those of you who subscribe to our IIoT report, you'll be having access to these slides. All of you will get access to the the audio or the video YouTube version that we'll be producing today. But there is a huge market in China. It's home to 20% of the world's population, but only 7% of its fresh water. So it really has embraced desalination with a big 5-year plan to produce 807 million gallons a day of purified seawater by 2020 and quadrupling the current capacity. So of China's 668 largest cities, at least 400 already suffer from water scarcity. So this is a big market in China. And we have a number of slides here that go into all the details and how much RO penetration, the problems with alternative methods such as rerouting water from the Yangtze River, and it's not really that practical. The impact of foreign technology, alternatives are not that attractive. A lot of the desalination so far in China has been industrial. And there are certain localities, obviously, that are with the most water scarce, that are the most active. And the people like Shenua are some of the largest potential purchasers of flow and treat. Shenua and Godium have just emerged, and between the two of them, they're operating 225,000 megawatts of coal-fired power plants. The United States is only operating about 260,000 megawatts of coal-fired power plants. So you've got one Chinese company that is operating as much as essentially all the coal-fired power plant operators in the United States, and more than all the ones in Western Europe. There are a number of processes that are promising for reducing the cost of the membrane approach, and Oasis has a system in here in China with forward osmosis, and that looks promising. The one other aspect in dealing with the Chinese market is you are selling to companies that are providing systems outside of China now. I mean, there was the internal activity, but now you're actually getting the Chinese OEMs and EPCs working to sell a lot of equipment in places like Vietnam, and this is one example there. And Hong Kong's a pretty good potential. And there are privately owned plants. In fact, even in municipal water treatment in China, there are a huge number of people like Veolia and Suez and so forth. I think one or both of them provide more than 20 million people in China with water. So the privately owned systems are important. And there are some local Chinese companies that are involved here, but many of the components and much of the system design presently comes from outside the United States, outside of China. And there are some engineering companies involved that are in China as well. And again, this is Shenua, who I was mentioning before, is not only involved in power plants with their Guodian acquisition, but it's one of the largest coal companies in the world and does have coal to chemical activity, which is huge as well. And there are some local membrane companies, but most of the membranes are coming from overseas. One of the things we wanted to do was to go through a specific plant and show you how much of the flow and treat equipment there is in one. And so here's a 678 megawatt plant where Doosan was selected as the EPC for the combined desal and power plant. And then they had Suez design and build and operate the Seawater desalination plant. And so you've got pumps and valves and so forth for 2 kilometers from 10 seawater wells. You've got 38 horizontal pressure filters here. You've got cartridge filters. You've got 14 first pass RO trains and 7 second pass RO trains. And all these, of course, have various pumps and valves associated with them. And so, for instance, here you see 29 major pumps just from the Seawater, the turbo pumps, and the 8 pumps into the second pass RO. And you've got auxiliary pumps and valves, and of course, when you get to some of the treatment of the brine, you get into sludges as well. We won't go into some of the options on the technology, but reverse osmosis is becoming more popular, but there still is multi-stage flash systems, and the percentage, though, however, of the RO is pretty high compared to the other technologies, and I think we will continue to see that. But there are some intriguing hybrid combinations, particularly in a power plant, where you already have waste heat in the power plant. So for using that waste heat in the power plant can be very synergistic, even if you're using an RO system for most of the dewatering. So the slide deck does get into the advantages and the details of a lot of these systems, but I'm going to skip over some of that. Again, the slide deck is prepared in such a manner that most of the discussion is included on the slides and doesn't need the verbal treatment. These plants, a lot of them are big. You can see there are 3 pumps on this particular plant. Each is 5.5 megawatts. So those are pretty big size pumps. The selection of elements is an art, and here's that discussed. The advantages of the MED are some. Electrochemical desalination is something that Evoqua is pushing. They call it a major advance in electrodialysis. And the NextEd system is used for brackish water desalination. So it'll be interesting to see that development. But I think a theme here is that the RO systems, or let's say the membrane-based systems as opposed to thermal, are providing advances that make them more and more competitive. And this would be true of your membranes. Peter Cartwright of Cartwright Consulting couldn't join us this morning. He's giving another paper today in a conference, and so he couldn't join us, but he's an expert in this area. And he is pointing out the developments in these different areas. Spiral wound RO membranes are still the very popular and most popular way to take out your ions in a reverse osmosis system. They have the lowest cost, they're interchangeable, and have excellent rejection. But they are the most susceptible to fouling. They cannot be backwashed, and they're very sensitive to oxidizing chemicals such as disinfectants. There are MF or UF membranes that are hollow fiber or tubular configuration that can be used for pre-treatment, and they provide submicron filtration. They're backwashable, chemically resistant, economically competitive with traditional pre-treatment technologies. And there are many choices of suppliers, designs, so forth. Here's the discussion of the differences between the 2 types of membranes and how some of these are used. But the Japanese membrane manufacturers have taken a big chunk of the Seawater RO membrane market. Dow Chemical out of the US would be the exception there. But in terms of the membrane suppliers, you can see here that Dow has only got a 4% market in the UF-MF membranes, although they would have a very big market in the RO membranes. And Siemens is now no longer in this business. So this is a little bit outdated slide here. But the point is, with GE and Suez now, you have a very big player in the market. The costs, the bottom line on costs here is that the RO systems are becoming less costly than the alternatives. And the opportunity, though, is to reduce the power consumption. And with a 5-year lifetime on membranes, to improve that, and more importantly, to improve the chemical treatment, some of these other aspects that can be achieved with improved designs. We talked about the TAQA being the largest operator, but we do have both public and private companies that are operating these systems, and 25% of all the capacity additions in 2015 were by these 25 top companies. And they, with the commissioning of its Carlsbad plant, Posidion Resources became the first U.S. company to rank among the top 25 private operators globally. But TAQA is one of the largest desalination companies in the world. It is the majority owner of 8 power and water plants across the UAE and supplies more than 90% of Abu Dhabi's power and water requirements. And it's moving into other areas and so forth. So looking to invest in Ghana and other African states. So it is a big player. There are companies such as Aqua Venture, which is seeking out existing desalination plants with legacy technologies, acquiring them, and then converting them to long-term water-as-a-service contracts. So I think this is very important in terms of our whole concept of the IIoT and remote O&M, because if you can keep improving performance, a water-as-a-service company can make a lot of money, but it requires better and better operations. So what they're doing is they're upgrading the technology. They might even convert one plant from thermal to reverse osmosis, which then makes it cheaper to operate. The fixed amount per gallon over a period of 10 to 20 years then would give them the incentive to try new technology like forward osmosis or nanomembranes and other improvements that would reduce the total cost of ownership. So I think this whole idea of monitoring and fine-tuning the systems goes along with this water-as-a-service type of contract. So Veolia and Suez are both big players in all this, and in a lot of other places where all the combust flow and treat is used. And so that Veolia has 12 million cubic meters of water produced every day in desalination plants that they've designed. Now let's get into the valves. The valves are challenging, and I believe we have Sudhir Rao on the phone here with us from Bray. Would you care to make any comments about the selection of materials that Bray has undertaken for their corrosive environments and high salinity and so forth there? Yeah, please feel free to make a comment at any time, but basically Samson is offering several options for the corrosive environments, special materials and surface treatments to provide and protect the equipment in the harshest conditions. And for high salinity media such as brine, most metals would corrode very quickly, even standard stainless steels. So Samson offers a full range of control valves and duplex, super duplex, as well as PTFE, PFA line valves to resist these corrosive media. The water generated from a desalination plant will often be used as drinking water, meaning that it has to be purified and remain sanitary. So there you need to design the valves to meet FDA and other sanitary, hygienic, and aseptic applications. Cavitation with these big pumps is certainly another problem. So due to the high pressure required for reverse osmosis, several of the control valves may experience high pressure drops and varying levels of cavitation. Samson offers anti-cavitation trim options, which are able to reduce or completely eliminate cavitation in the valve. We have been covering Samson in a number of our IIoT and remote O&M webinars. One was with where we covered the BASF condition monitoring, and it underlines our point that these large companies like BASF are making central decisions. And so, for instance, they have designated that Samson valves and E&H monitors be used in condition monitoring systems for the valves in all their plants around the world. So there are a number of valve suppliers, and we just want to get representatives of some of the different types of valves, from the pinch valves, butterfly, diaphragm, plug, check, air release valves, knife gate, ball valves, and globe valves. So the Bray provides valves for both types of desalination, and we do have someone from Bray along here as well. And so Sudhir Rao, would you care to make any comments about the use of Bray valves in desalination? So part of the strengths of the Bray valves is they offer the 3 disc to stem connections. So these internal non-wetted connections eliminate typically exposed external disc to stem connections such as screws and taper pins. Again, addressing the corrosive fluids, Bray offers a full line of valve materials to combat the problem, with resilient seated butterfly valves using nylon 11 coated discs for seawater, and they're using that routinely with little or no corrosion. And they use a range of nickel and nickel aluminum materials as well. And they have a specialized advanced ball valve suited for the harshest service, from metal seated to double offset high performance, cryogenic to triple offset. Bray has a range of products for these applications. To give you some idea of how many of these valves go into a plant, Hebei Valve has got 1,500 butterfly valves just in the Ashkelon plant. ABK has 700 butterfly valves in the Andalusia, Spain plant. Rohrtech has a large number of its intelligent actuators in a 230 million euro plant in Barcelona, Spain. Flowserve provided the plug valves for the Southern Seawater Desalination Plant in Australia. Mezzo Automation delivered 300 control valves for the CIDEM France plant that was I guess the location is not given here, but anyway, for one plant. And KSB got a double-digit million euro order for a new seawater plant in Western Algeria with 64 pumps and 1,000 butterfly valves. So Victaulic acquired MTS and plays a major role in joints and valves for desalination. And Luis Imperiale is with us today. Luis, were you able to get on the voice portion of the program?
Yeah, here I am.
Oh, okay, good.
Yeah, good morning, everyone there. Good afternoon for me.
Very good. Yes.
I'm listening. Very interesting presentation from your side.
I'm sorry. Can you speak up a little bit louder?
Yeah. Are you hearing me okay?
Yeah, we can hear you okay now. So we have several different slides here, and we wanted to start out with the fact that Victaulic had purchased MTS valves, and that you do have the plug valves and other high pressure membrane treatment valves. So would you like to go through the advantages? I think one of the things that is important here is that Victaulic also furnishes the joints or coupling, so it's very advantageous to be able to provide the groove couplings, fittings, and valves for the high pressure desalination. Now, Lewis has sent us a bunch of slides here, and if you would like to then go over these slides, Luis, that would be helpful.
Yeah, definitely. It's just a few words about the acquisition of the MTS brand. As you know, we have been in the market of the desalination for a long time ago, but just supplying our flexible couplings for the control of the movement of the membranes. But understanding the market, we saw that it would be really interesting for us to incorporate some other products where our system it could be included, especially in this case for the plug valves, which traditionally are using it with a butt welding connection. When I saw that, we understood that including our connection, grooved connection, we can be introducing a high benefit to the system or to the market, sorry, because of course the advantages in terms of installation, considering the way of work of this market in terms of construction of the plant. I'm talking about the piping itself, of course, and 100% linked to the prefabrication, and that our system is exactly linked to the prefabrication too. And we did the acquisition of the MTS plug valves, and right now we are producing by ourselves with the MTS brand, but as a Victaulic product. And we are able to offer the different options. The system that traditionally is used in the market with the butt welding connection or the flange connection, and of course what we are doing is pushing a lot to introduce our groove connection to the system. The main advantages of this introduction of the groove connection is definitely linked to the prefabrication stage, because today most of the cases these kind of valves has to be welded on the pipe spools, which means it's taking time and risks due to the welding characteristics, and a lot of time because you have to ship the bulbs to the prefabrication shop, and then once the bulbs are already welded in spools, you have to be shipped again to the shop site, which means it's to transportation, the risk of on transportation, and they need to be asking for the bulbs in advance due to the time of fabrication and then the time to be welded as a part of the spools. In this case, the main advantages is to save time in installation, which means, of course, save money, and to give an advantage in terms of maintenance. Beyond that, people think that the maintenance of this kind of bulbs, it's easy because it's coming from the top. But at the end, if the bulb is welded and you don't have any option, and the position of the bulb is fixed, once using our system, you have the chance to be rotating the bulb to the position able to be removed, or even to be doing some maintenance, and then to be putting again in the position that the maintenance department needs to save space many times. This is the main reason or the main advantages we found, and especially about the welding systems, because it's traditionally or normally it's not the same to be welding duplex or super duplex material than in other markets where it's carbon steel pipes. In this case, you need very qualified people, right?
Right, I can certainly see that as well. And of course, if you have any line valves or something, it would be particularly concerning to be welding there. So we do have a couple other slides there. You might just explain some of the plug designs here.
Yes, in this page you can see the three different types of, because the bulb itself is a very simple bulb, and it's an on-off bulb to isolate systems. But we do one step ahead and creating some different kind of plug designs in order to be able to get some level of control. You have what you do, of course, is to create differential pressure and to improve the curve, the characteristic curve of the bulb, in order to be able to do more control than with an on-off bulb. If you go to the next one.
Yeah.
This is just to show what we do and how easy it is to install the bulb, because whatever is the size, the connection is always the same, just using 2 bolts and nuts. The next one.
Yeah, that does look quite simple there.
Yeah, in this case you can see a picture from a plant already installed. It's a really easy way to be installed, with just 2 couplings, 4 bolts and nuts to be installed. And in the case you need to rotate the bulb, it's just to untight the bolts. You can rotate, you can do the maintenance, and then you can rotate again to put in the right position and tight again. It's really simple.
Yeah, that does seem simple, yeah.
As you can see in this one is a small drawing. It's not very clear, the view, but it's at least to show how easy is the installation or the components on the system, because at the end it's exactly the same system that you know everywhere in the world with our system. It's just a gasket, 2 housings, and 2 bolts and nuts.
And there might be Victaulic couplings elsewhere in the system too, so there's some synergy as well, right?
Yes, definitely. We have been working with the market itself. I mean, with the different customers, in order to be developing different products to be giving solutions to the market. At the beginning, the market has been using just flexible couplings for the connection of the membranes to compensate movements. But time to time, we have been discussing with customers, and we have been introducing also rigid couplings, in this case, for high pressure applications. This kind of couplings that you can see here for the connection of a dual plate check valve are couplings for 82 bars, so 1.2 thousand psi. For duplex, super duplex pipe material, available for a Schedule 20 or a Schedule 40. It depends of what the customer wants to use. You know that it depends of the designers. Some plants are using Schedule 20, some others Schedule 40, and we have the option to be working for both options with our system.
And in terms of other places in the system, would similar couplings be used for the pumps, for instance?
Yes, it can be, of course, but in this case, it depends of the pump manufacturers, because you know it's the pump itself. There has been included the group connection. You can find it for the small pumps manufacturers. Small, I mean, for the sizes, right? Like Danfoss, Grundfos. Today they produce the pumps with the group connection as an optional system, and not just with a flange. Even if you go to the energy recoveries, the connections they used for their own equipment. It's also with our system.
I see. And that's a big part of these plants too, those energy recovery systems.
Definitely, and they are. We have been working with them strongly in order to develop the right product, because they need flexible couplings, in this case, to compensate axial and angular movements. And with the use of the flexible couplings, they are able to compensate the vibrations and the different cycles transferred by the energy recoveries. In this case, this picture is showing a comparison between the traditional system to install a wafer type dual plate check valve, which traditionally has to be installed between two flanges. If you consider in this kind of applications that the pipe is duplex or super duplex or SMO, and it's a very expensive material, and the flanges also are the class 600 flanges, which has to be welded, and then the amount of bolts and nuts you have to install. With our system, it's just two couplings with the 4 bolts and nuts. It's extremely much easier to be installed, saving time and of course saving money. That's what we proposed today to the market.
Well, that's certainly very interesting, Luis, and I'd like to thank you for spending the time here from I guess it's part of the evening. Of course, in Spain, though, you're involved in pretty late evening,
yeah.
Are you not? Yeah, but
yeah.
Thank you very much for that.
I appreciate very much the time to introduce our system and myself. Thank you very much.
Well, thank you. Yeah, and we are moving on to just some of the valve locations. For instance, this is on the seawater intake, and these would be the types of valves that AVK would be furnishing just for the seawater intake here, with check valves, ball valves, and butterfly valves. Crane triple offset valves are dealing with the high pressure desalination applications that you would get into, and certainly in the thermal and other applications here, where you'd get high temperatures as well. And they're used in a range of applications, and they do have a number of media types as well that can be supplied. The actuators are very important, and Auma is certainly one who has been a pioneer in flow control for valves at desalination plants, and here's one example. Then on to automation and controls generally, Yokogawa's been a big player in this area. And for instance, in this very large plant, they had their Centum VP integrated production control system and safety instrumentation systems installed here. And this is a plant here that will be in Doha that's going to be in operation here next year. There's a lot of aspects to even the initial programming, and this is what this Krenger slide's all about here. Rockwell is automating many of the desal plants with their PlantX process control systems. ABB provides controls as well, and they provide complete system solutions with the electrical grid connectivity, control and instrumentation, drives, motors, and mechanical packages. So they delivered a solution based on the Symphony Maestro operational control and automation system for the Jeddah plant. And this was an improvement and then over the existing and obsolete DCS system. The monitors are needed not only for all the aspects of the processes, but also for the effluent water quality. So they can be used even in the feasibility and design stage and monitoring the effluent, for instance, in the outfall. The remote monitoring is coming on strong in the industry, and Osmoflo PlantConnect is one such system for remote monitoring and control. Pentair provides the monitors with a network of buoy-mounted monitoring systems that would measure salinity and oxygen to prevent any problems where you're discharging your brine. And of course, this is a consideration of all these plants, is making sure that the discharge to the sea complies with environmental requirements. A lot of the combust flow and treat, as we said, is going to be purchased by the Veolias, the Doosan's. You notice GE here and Degramont are now all part of Suez. So Veolia is got a competitor now of equal size with GE and Suez in this arena. Saudi Arabia is where the most systems were as of 2015. And of course, the Mideast dominates with the USA and then China coming on as a rapid growing area as well. So Veolia has 1,700 systems in 85 countries and many decades of experience. Suez has over 250 references in the 70 cities around the world. But the GE Suez merger creates a company that's broadly based now in instrumentation, equipment, engineering, operation. And with the GE bets, they've got the chemicals now as well. And then, of course, they do have all the digital services as well. So they are competing more broadly now with some of the other companies that are more narrowly focused. And some of them, like Xylem, don't supply the chemicals, but are in a lot of the other areas. Camara would be big in the chemicals and so forth. So these are, it's kind of an interesting comparison and part of the rationale for the GE and Suez merger. And they are treating brine as well. So there's a Suez and Solvay joint venture to treat the brine, which is certainly an area where there needs to be even further improvements. Suez and Veolia and others are building and operating plants, and this is a new one that's going in by 2020, and Suez will be operating it. The Aqualung is one more entry here, and they've got plants in 8 different countries. So this takes us through the presentation this morning, and I'd like to thank you for joining us. And this is Bob McElvain signing off for today, and look forward to having you at future conferences.